Alright, you've made it to the end of HMIs, human-machine interfaces, and by this point you should have a pretty clear understanding of what goes on behind the scenes of an HMI. When it comes to setting one of these things up, you might have to stop and check a help menu or look in a forum once or twice, but you really should have a good concept of what goes into developing a set of screens for a project. Beginning with tags, there's addressing them to the PLC, establishing communication, whether it's with an IP address or the name of a processor in RS links. That just depends on the platform. After that, setting up displays shouldn't be any problem. It's time consuming and you'll want to experiment with the different controls available in your HMI. But you have multi-state indicators, you have push buttons, you have numeric displays, text displays, numeric entries, and these are things that you see across the board on almost all development environments. You have little lights and bulbs and meters and things like that. The animations are a lot of fun to play with, and different environments have different animations and visibility effects, and they all tie back to tags in the PLC. Speaking of tags, addressing those to different PLCs, understanding the idea of a B and an N and an F value, bits and integers and floats, by this point should certainly be no mystery. You should have a clear understanding of what those are and how to bring them into the HMI. Some HMIs, including the one that we used today, also have the option of limiting the operator input to within a certain range. That's very helpful in protecting the PLC program from erroneous entries. If you want a percentage input, it should be from 0 to 100. You don't want an operator to be able to come along and enter negative 6,000. Who knows what that's going to do to a running program? Other than that, setting up alarms in a PLC is the same as almost any control. You associate each alarm with a tag. You generally put a message in, and you're going to want to have two different controls for most HMIs. To manage alarms, you're going to want to have, at a minimum, an alarm reset and an alarm silence button, and those are going to tie back to the actual management of the alarms and notification bits inside of the PLC. The last thing we covered in this section was management of permissions and runtime security in an HMI, and that is as simple as setting your security code to each individual control or each individual screen to which you want to limit access, and then setting up your user group, which can include as many different users or groups as you want, depending on how many different levels of access you need in your program. None of these concepts are going to really be mastered by watching videos. This is a great way to learn how these things work. This is a great introduction to these things. But in the end, what's going to make you a master and ready to go out and create programs and HMIs is to practice. And after you've developed a few sample programs, a few example HMIs, you've worked through some of the bugs and difficulties of establishing communication across different devices and HMIs, and almost no two setups are ever the same, then you're probably ready to start doing this for a living and to start getting paid for doing it. HMI development isn't what comes to mind when most people think of machine programming. The ladder logic, the bits and the floats are usually the things people think of, but almost any PLC project is going to have an HMI, and it's very rare that you're going to have two different people developing. So if you want to program the logic, you're really going to have to learn how to do the screens, how to set all of those controls up, and how to make it all work together. In the end, none of this stuff is hard. It's all pretty easy to learn. It's all pretty easy to master. It takes a little bit of study and a lot of practice. I'll see you in the next section.